Hi, my name is Ashwani Kumar. In this video, we are going to see the UGC June 2019 questions on the unit that is transducers. So, as per the UGC Electronic Science syllabus, the transducer is the 10th unit. So, here we are going to see all the questions on this unit. The first one is a capacitive transducer can be used for the measurement of. So generally the capacitive transducer means it based upon the main formula, that is C is equal to epsilon A by D. So if you take the two parallel plates and both these two are the terminals of these two plates, and in between both these two plates we are considering one medium that is called as a dielectric medium. Okay, and the distance between the both these two plates, let's take it as a small d, and the cross sectional area of both these two plates is capital A, and the permittivity of this dielectric medium is epsilon, then C is equal to epsilon A divided by D, or else epsilon can be given as a epsilon naught epsilon or A divided by D. So it is a permittivity of the free space, anyhow it is a constant, and it is a relative permittivity of the which type of dielectric medium we are taking, and remaining is the cross sectional area divided by distance between the two plates. Okay, so the capacitor transducers are generally used to measure the moisture in the soil, thickness, and the displacement, and the humidity in the air also we can measure with the help of capacitive transducers. Okay, so generally while coming to the moisture means if we kept a soil with some moisture in between both these two plates, that means the soil is acting like a dielectric medium. Then if the moisture is there, then the dielectric medium, that means the epsilon r will change. If the moisture is not there, then the epsilon r will be the different. So based upon this epsilon r, relative permittivity of the soil with less moisture or soil with high moisture, the capacitance will change. Whenever the capacitance is changing, then automatically based upon the change in capacitance, the amount of moisture we can measure. In the same case, while coming to the thickness and the displacement, so while coming to the thickness means here whatever the material you want to measure, that material we are going to kept in between the two parallel plates. So now if we are moving this capacitor, that means if we are sliding this capacitor throughout this material from left hand side to right hand side, so here based upon the thickness, the distance between the two plates changes. Whenever the distance between the two plates changes, then the capacitance value also changes. So the change in capacitance value is directly proportional to the thickness of this material. And coming to the displacement, so generally the displacement means here we are going to take the capacitor, parallel plate capacitors like this. Okay, so we're going to take the two plates like this, not in the same alignment as I considered here and here. Here the two plates are kept like this. One is a fixed capacitor and another one is a flexible capacitor which is free to move. So whatever the displacement you want to measure, we are applying that displacement to this flexible plate. Then this flexible state plate start moving in the zigzag, that means in the to and fro motion. Then here the cross sectional area of both these two plates changes. Whenever the cross sectional area changes, then automatically capacitance also changes. So like that, the correct answer to the first question, that is the capacitive transducer is used to measure moisture, thickness, displacement. That means all of the above is the correct option, and it is a proper explanation to all these options. And here we are going to see the next question, the second one. Here the question is, a sinusoidal voltage is measured by the cathode ray oscilloscope. Vertical distance between the positive and the negative peaks is 8 centimeter. If the scale of the CRO is set at 5 meter volt per centimeter, then the peak value of the voltage will be. So generally, if you observe the lecture of the CRO, generally the CRO screen is just like a grid like of screen. That means a grid type. So grid type means it is divided into the few horizontal and vertical segments. Okay, and both these two are the reference. It is a origin, and it is a horizontal segment reference, and it is a vertical segment reference. And after this one, we will be having the few lines like this: 1 2 3 4 5, and 1 2 3 like this. So here also 1 2. So the CRO screen is divided into the grid like of structure like this. And here the question given is a vertical distance between the positive and the negative peak is 8 centimeter. Generally here from here to here we are going to take as a one unit. Okay, so in the CRO screen Above the origin, 5 such type of units will be there, and below the origin, 5 such type of units will be there. In the same case, in the CRO screen, to the left side of this vertical reference, 5 segments, and here also the 5 segments will be there. And here they given that the vertical distance between the positive and negative peak is 8 centimeter. Okay, so generally positive peaks are lie in the above the origin, negative peaks are lies below the origin, right? So from positive to negative peak, the vertical distance is 8 centimeter, means here it will be having the 4. Okay, generally the 4 segments. Okay, let's take the one more line here. 1, 2, 3, 4. Okay, so 4, and here below also 4. Okay, that means from origin to here 4 segments, and from origin to here 4 segments we are going to take. Okay, so that means the positive peak, the peak voltage is 4 volts. Fine, the positive peak is 4 volts, and the negative peak is also 4 centimeters here, and here also the downwards is also the 4 centimeters, not the volts, 4 centimeter, and here the negative peak is also 4 centimeter, right? And here the CRO scale is 5 millivolts per centimeter, 5 millivolts per centimeter. Then the peak value of the voltage is, so generally they given that one signal is there, the vertical displacement from positive peak to negative peak is 8 centimeter, right? And what is the scale they given here? 5 millivolt per centimeter, 5 millivolt per centimeter. Here how many centimeters are there? 8 centimeters are there. That means for 1 centimeter they mentioned 5 millivolts as per this thing, and for 8 centimeters we are going to get how much volts? So 5 millivolts into 8 centimeter, that means 40 millivolts, right? That means from here to here it is 40 millivolts. So from here to here means it's nothing but V suffix peak to peak. It is called as a peak to peak voltage is 40 millivolts. But in the given question they are asking only the peak value. So peak value means peak value is equal to peak to peak voltage divided by 2. That is 40 millivolts divided by 2. That becomes as equal to 20 millivolts. So 20 millivolts is the correct answer. Okay, so the first option is the correct one, and it is a way of solving. So for solving this question you have to know that the screen of the CRO is divided into the several vertical and horizontal segments. That means it's just like a grid like of structure. And here in the question they given that 8 centimeters from positive peak to negative peak. That means you have to understand that the peak to peak voltage they given, the peak to peak distance they given as a 8 centimeter, and for 1 centimeter 5 millivolts, means for 8 centimeters it is 40 millivolts. So 40 millivolts is the peak to peak voltage, but in the question they ask the peak voltage. So peak voltage is nothing but peak to peak divided by 2. Okay, and while coming to the next question, so it is a third question we are going to see now. So in a Chering's bridge, dial of variable capacitor is calibrated directly in terms of a dissipation factor of unknown arm. So at 50 Hz frequency, the value of dissipation factor of unknown capacitor was found at D. That means at 50 Hz, the dissipation factor of the capacitor, of the unknown capacitor, is capital D. And what would be the value of the dissipation factor at 60 Hz? That means they are asking for at 60 Hz, what is the value of the dissipation factor. Okay, so generally if you observe, the Chering's bridge is used to measure the capacitance value, that means the unknown capacitance value. So it is a Chering's bridge. So here R1 and C1, both these two can be called as a RX and CX, where both these two are the unknown resistance and unknown capacitance. So we can find out both these two with the help of known resistance and known capacitances here. And coming to the dissipation factor, the dissipation factor of not only the capacitor, that generally the dissipation factor is nothing but a losing of energy, the rate of amount of losing the energy. It happens due to the internal resistance of the capacitance. Okay, so in the Chering's bridge, the dissipation factor of the capacitor formula is omega into Rx into Cx, right? Omega, that is omega is nothing but angular frequency. Okay, so angular frequency is nothing but omega can be taken as a 2 pi f, right? Rx into Cx, and where F is the frequency. What is that frequency? The frequency of the applied input signal. Okay. So it is the formula to the dissipation factor of the capacitor in the Chering's bridge. So based upon this formula, here they are asking that at 50 Hz, the dissipation factor of this capacitor is D, and what about the dissipation factor of this same capacitor at 60 Hz? Okay, that means they are not changing any resistor and capacitor values of this circuit of this bridge. They're just simply changing the frequency of the applied input signal. Okay, so anyhow, let's take the dissipation factor D is equal to 2 pi into F 50. Why? Because at 50 Hz, the dissipation factor given is capital D into R into C. So instead of Rx and Cx, I am just taking R into C. And from this one, 2 pi into RC can be written as D divided by 50. Right? So let it be equation 1 like this. And now, while coming to the dissipation factor dx, so dx is nothing but, I am taking this dx is nothing but the dissipation factor of the capacitor at 60 Hz is equal to 2 pi into 60. F in the place of F, I am writing 60 into RC. So here now dx can be given can also be written as a 60 into 2 pi into RC, that is equal to 60 into, so here 2 pi into RC I got from the equation 1, I got as a D by 50, right? So D by 50. Here 0 0 gets cancelled, so finally I am getting 60 by 5. That means if the dissipation factor of the capacitor in the Chering's bridge at 50 Hz input signal frequency is capital D, then at 60 Hz frequency, that is dx is equal to 60 by 5. Okay, so here the correct option is 6D by 5. Okay, so it is a way of solving such type of problems. So to solve this problem, you must know the dissipation factor formula of the Chering's bridge, that is D is equal to omega into Rx into Cx. And now next, while coming to the fourth question, the list of transducers are given below, and which of the above are the active transducers. So as I told that transducers are generally based upon the supply or self-driven. They are classified into the two types. So one is the active transducer and the second one is a passive transducer. So generally transducers means they has to convert the one form of energy into the other form of energy. Active transducers means for this conversion process, they don't require any type of additional power supplies, right? But while coming to the passive transducers, definitely they require some additional power supply to convert one form of energy into the another form of energy. Okay, so here photovoltaic and piezoelectric, both these two are comes under the active. They don't require any type of additional power supplies to convert one form of energy into another form of energy. So generally here the photovoltaic cells are used to convert the optical energy into electrical energy. The photovoltaic cells are also called as a solar cells. Okay, so they simply exposes to the sunlight and absorbs the photon energy and liberates the free electrons, which we can store in the battery. Okay, and while coming to the piezoelectric crystal, so the piezoelectric crystal is nothing but it's having some piezoelectric property. It is having the three axis means one is a y-axis is the mechanical axis, x-axis is the electrical axis, and z is the optical axis. That means if we apply the mechanical energy on this crystal, then it produces the two different types of energies. One is electrical and second one is optical energy, vice versa. If you apply the electrical energy, then it produces the mechanical and optical energy. But here we are considering only the two different types of energies majorly from the piezoelectric crystal, that is mechanical to electrical and electrical to mechanical. Okay, so for this purpose, the piezoelectric crystals will not take any type of additional power supplies. Okay, they itself converts. So both these two B and C are the active transducers. That means the correct option is the second one. But while coming to the photoconductive cell and thermistor, definitely they require some supply. In the photoconductive cell, here we are taking one resistance like this. So based upon the light intensity, the resistance value changes, and based upon the change in resistance value, the current flowing through the loop also changes. And coming to the thermistor also, we are taking one resistor. The resistance of this resistor changes based upon the surrounding temperature. Whenever the temperature changes, the resistance changes, and the current flowing through this loop also changes. So that's why both these two are the passive transducers.